Alright, now we're turning our attention to the shader for the ground plane, and we are creating a shader node to ray trace a shadow. So I'm going to just demonstrate that that does indeed work by moving the light around. Alright, and I will show you the node for that and explain that roughly, what we've done. This first set of nodes up at the top was our original node where we calculated the Lambert shading for the surface. And down here at the bottom we've added a logic and a ray trace node to create that shadow. So let me start from scratch by deleting those and also that, and plugging the shader back in to diffuse shading. As you see, we now have no shadow, but we are in fact shading that ground surface, and it is correctly being lit by our light, and we're not calculating a shadow for it yet. Alright, that is our basic Lambert shading node right there. To recap, we're using a dot product and multiplying the dot product of the vector between the light and the surface normal by the color to get our final shading. As we discovered, the intensity of the light is already being taken care of for us in that color parameter, so we don't have to do that extra. Alright, so we're going to add a few extra nodes here. We're going to need a vector multiply to combine the shadow color with the not the shadow color, but to combine the shadow with the surface color. And we're going to need a ray trace node, or a path trace node, I think is more accurate. If we had selected a ray trace node, you would see there's a color and length parameter. We don't need both, we just need the length. Maybe it'll be a little bit faster if we just do ray trace, where it just returns the length. Alright, so we will plug our, let's see, we need our position and direction. So that's probably the position of the world spot and the direction of the vector between the light and the world spot. So let's go ahead and plug in world spot, which is right there, and the direction coming from the light. And that's ray tracing. What ray casting rather, what that does, it returns the length of the ray that was ray traced. All we need to know is if an object was hit by the ray. So if an object is hit, the length of the ray will be, or if an object rather is not hit, the length of the ray will be -1. If it is hit, it'll tell you the length, but we just need to know if it hit something or not. So we're going to use logic to tell if that was hit or not. So under vector, actually it might be under, let's see, scalar, there should be a logic node. We're going to plug the length into A. We're going to test specifically for -1. If A is equal to B, then return true, otherwise return false. Let's see. We're going to plug that into our multiply, and we're going to plug the color of our surface into the multiply. So we should be multiplying the color by either 0 or 1. If it's 0, it should be black, and if it's 1, it should be the exact color of the surface. So let's plug that into our surface diffuse shading, and the first thing we're going to notice is that's not going to work. Why? Well, for one thing, I believe our, let me see, double check everything. Logic, testing for -1. If A is equal to B, then return 1 or 0. That's fine. We're ray casting, we're using the direction from the light, we're using the world spot as the position. So one thing that's wrong is that, as you remember, our vectors need to be pointed in roughly the same direction. They can't be opposing each other, in other words. So we have to reverse the direction of the light vector. So let's use a multiply as we've done before. It has to be a vector multiply. because we were talking about a vector. Let's plug that into multiply by -1 on each vector. Then plug that into the direction of the light. Alright, so that's the first thing we had to do. Let's see, make sure everything else is connected right. Let's see, A, B, and let's test this out by plugging this directly into diffuse shading. That actually works. Alright, in fact, you're seeing that we have a shadow. So, and it is indeed 0 or 1. So unplug that briefly. It plugs that into the diffuse shading. That's where something's going wrong. Let's see. Test this and make sure this is working right. Let's see. Multiply it by 1 and see what happens. That's not working right. So right here our result is incorrect. Well, here's a problem. I lost one of my vectors right here. Let's see. We have to plug in the dot product. That's our lighting. So we have to actually plug in color there. And now, as you can see, the shading is working. I had accidentally unconnected something. Alright, now we're going to multiply our surface color shading by our shadow. This should work now. As you see, that is indeed correctly calculating a shadow. I just misclicked on something. Not sure what. Let's see. There's my line. Alright. But as you can see, we are now correctly calculating a shadow for our light. Just to recap that one more time because I got a little confused. We raycasted a which is like ray tracing, a ray from the world spot, that's the spot on our surface that we're shading, in the direction of the light, or it's rather the opposite direction of the light ray. We use the multiply by -1 to flip that light direction. If we had not done that, let's see what would have happened. Well, exactly nothing, because that ray is pointing in the wrong direction. It's pointing in the direction of light, meaning our shadow would be off somewhere in space somewhere, I guess. So we're going to go ahead and plug that back in, and we do indeed have our shadow. Now that we have a shadow being ray traced, we use the logic. We tested for -1. Remember, if an object is not hit by that ray, it returns -1. So we said A is equal to B, B being -1. If so, return 1, else return false. And then we multiplied our original surface lighting times the color by our shadow, and that gave us our surface, and it made the shadow black because we're multiplying by 0 if there's a shadow. Alright, so that is basically ray tracing a shadow in Nodal. There are things we can yet do to this. We could, for example, create a slightly random vector which would give us a soft shadow. We could do that in several ways, but I'll do it in the simplest way just to get the idea across. I'll import a node and import our let's see, we have a somewhere here random normal, and we'll also use the lerp normal right there. Let's see, lerp normal, let me add that again, import random normals. So as you remember, that random normal creates a completely random normal, and lerp normal, that means linear interpolate between a normal or two normals. We're going to plug in our we're going to plug this random normal in as one of the parameters, and we're going to plug the normal from the surface of our spot that's being shaded. That would be the normal from our inputs right there. We're going to linear interpolate between that and the random normal. We're going to take the output and let's see, plug it into the, I believe, into, let me see what I'm actually doing here. And let's see, I think we want to plug that into our position. Is that what we want to do? No, that's world spot. I think we might actually want to multiply our light by this. Okay, let me think for a second here. I've gotten confused now. Position and direction. Alright, let's see. Direction is the light direction. Alright, so when this happens, oh, well, you just get confused. That's not a problem. So what we might want to actually do is direction, randomize this direction. Let's see, how can we do that? I will take, well, a direction is basically a normal. So I'll take this direction and plug it into the normal instead of the world spot normal. And I'll take that and plug it into the multiply mode up there. This is going to be a little bit strange because remember there's one more parameter we have to set, that blend value, which is a not a vector but a scalar, but it's not under scalar. We have to go to where it says constants and pick constant scalar, which just lets us just input one value between 0 and 1 in this case. Plug that in as our blend value. Ooh, and something already happened. Our value is 1, and that gave us a completely random normal. I'm going to take it down to like 0.1 and see what happens. There we go. Now we have a slightly blurry shadow. In fact, this is at least somewhat like dome lights in a way. I'm going to move that around so we can see it better. But yes, that has given us a realistic soft shadow, and if we want to experiment with that a little bit more, we'll change that scalar value to 0.4. That gives a much softer shadow. Sorry, 0.001, a very hard shadow. 0.01, 0.02, slightly soft shadow. 0.05, a little bit more, and so on. Alright, so just goes to show you change your mind every once in a while on some things you learn as you go. Alright, so to recap, to create a soft shadow, after we ray traced that shadow and combined it with using a logic and then multiplying it with the surface color, what we did was, oh boy, we changed the direction, not the position, but the direction, which is originally the actual direction of the vector of the oh boy, the vector pointing from the surface to the light, or the light to the surface spot that we're shading. We changed that to an actual random vector, which we interpolated or blended with. Let's see, we blended that with the vector of the light, which is the a line pointing from the surface normal to the light itself, or a line pointing from the surface spot to the light itself. We blended that with a random normal, and as I said before, a normal is basically a vector, so this actually worked. It's basically giving us a random vector. And that is basically all there is to creating soft shadows within Nodal in Lightwave 3D. Alright, so hope that's been understandable. Thanks again for watching. I hope it's been useful to better understand how lighting and shading works within Lightwave and in 3D in general. I hope you enjoy working with Nodal and Lightwave. It's very powerful. As you can see, we can very quickly block out basically we're creating plugins in after a fashion for Lightwave, but we're doing it in a way that is visual, and you can see the output as you create it almost instantly. There's no waiting for software to compile, or you don't have to do the grunt work of creating all these different 3D components. It's all there for you. So I very greatly encourage you to explore Nodal, explore what it can do for you. There's so much you can do with it. It's really hard to sum up in just a few tutorials, but that is just one example of how you can create some things from scratch. It gives you some basic understanding of if you get stuck with a feature that's not in Lightwave, you can pretty much make it yourself now. That's about all I'm going to say for it for now. Thanks for watching again. Talk to you later, and ta-ta for now.